So the first part about this chapter is just classifying matter, and there's two categories that it could fit into. One is a pure substance, which could be an element, and the way you can tell it's an element is that you'll recognize it from the periodic table. So any of the boxes on the periodic table are going to be just pure elements. If you chemically combine those elements, you can make a compound. And one way to tell if it's a compound is if you can ask yourself, do I know the chemical formula for this thing? Then it's probably a compound. For example, you know that water is H2O. You know that carbon dioxide is CO2. You probably know that sugar is C6H12O6 from biology. So even if you didn't know what the formula is, if you know that there is a formula out there, it's probably going to be a compound. If you mix two things together but you don't chemically stick them together, we call them a mixture. And there's two different categories there depending on whether or not you mix them uniformly, and it has to do with the size of the particles. So for sweet tea, once you mix it up, you're not going to have part of the tea that's sweet and part of it that's unsweet. And that's because it's mixed uniformly. Heterogeneous things are not necessarily mixed completely. So like for a chocolate chip cookie, if I break it in half and give you half, you might have 2 chocolate chips and I have 3, which means it's not necessarily mixed completely. And heterogeneous mixtures tend to have bigger particles as well. So homogeneous means you have really tiny particles that are not going to separate out. So like if you put soil into water, eventually the soil would separate to the bottom. That means that it's heterogeneous. And if we're talking about homogeneous mixtures, there's 2 different words that you need to be familiar with. And they sound similar, so you need to be able to get these into your vocabulary. Solute is the thing that gets dissolved. So if you make sweet tea, the sugar is the solute. Solvent is the thing that does the dissolving. So the tea would be the solvent. And if water is the solvent, the word we use for that, we've used it before, is called aqueous. That means that water is the solvent. So if you look at that picture, notice that the yellow dots are the solute. That's what gets dissolved. The solvent is the blue liquid. That's what's doing the dissolving. And there's a couple of different steps for what happens when something dissolves. The first step is dissociation. To dissociate means to break apart. So if you were going to make salt water and you put the NaCl into the water, the first thing it's going to do is break apart into ions. So you have Na plus and Cl minus. Then the water is going to surround the ions, and that's called hydration. So if you look at the picture, the green and gray compound is your NaCl, and then the little blue Mickey Mouse looking things is the water. So the first thing that has to happen is that one of those pieces is going to break off. And then notice in the second picture how the green sodium got surrounded by the water. So all the little Mickey Mouse things are surrounding it, and that's called hydration. And once it surrounds it, now that it's just like one atom big, you can't see it anymore. So it's so small that you just can't detect it, which is why it looks like when you dissolve something, it looks like it disappears. But it really just breaks into tiny particles. So first it's going to break apart, then it gets surrounded by water. And it's important that you realize which part of the water is going to surround it. So the sodium, since it's positive, it's going to be attracted to the negative side of the water, and the oxygen is the negative side of that. The chlorine, since it's negative, it's going to be attracted to the positive side of the water, which is the hydrogen end. So remember, water is polar, which means that the charges are lopsided. So the oxygen side is kind of negative, and the hydrogen side is kind of positive. So whether or not something dissolves is all purely based on forces of attraction. So if you look at this crystal here, the green and gray pieces, if they were held together with really strong forces of attraction, the water would not be able to break them apart. But if the ions are attracted to the water, then they will break apart, get surrounded by water, and that's what we call dissolving. So it's all purely based on which force of attraction is greater. And I want you to look at that picture and notice that for the chlorine, for the green one, notice that only the white hydrogen parts of the water are touching the chlorine or about to touch the chlorine. And that's because chlorine is negative, but the hydrogen side of the water molecule is positive. Same thing for the sodium. Notice that only the oxygen is touching the sodium, and that's because oxygen is slightly negative. while sodium is positive. If something is insoluble, in means not. So that means that it cannot dissolve. And that's because the force of attraction within the compound is strong enough to overcome the water. So the water's not strong enough to break it apart. And when you're trying to figure out if something dissolves, we use the phrase like dissolves like. Dissolving is a physical process. So first of all, it's not chemical. And the rule like dissolves like refers to covalent compounds. So nonpolar solvents can dissolve nonpolar things, and polar things can dissolve other polar things. But if you have something that's polar and something that's nonpolar, they will not be able to mix. So like dissolves like refers to polarity. Polar dissolves polar, and nonpolar dissolves nonpolar. And just to review, in case you forgot how to tell if something is polar, you can't have any extra electrons on the central atom, and you can't have different elements on the outside. If you have either of those two cases, it's going to be polar. So to be nonpolar, both of these conditions have to be met. The next word is electrolytes, and this is exactly what it sounds like. It's something that conducts electricity. And the way that it does it is because it has floating charges. Anytime you have charged particles that float around, you're going to be able to conduct electricity. So we call them mobile ions. Mobile means that they can float around and move, and ions means they have a charge. So anything that's ionic, once it breaks apart, is going to have a charge on it, and so that's why ionic compounds are electrolytes. We haven't learned about acids and bases yet, but we're going to get there in the next few days. Non-electrolytes cannot conduct electricity. So these are things that would, when they break apart, they don't break into charged particles. So some examples are sugars, alcohols, and things that are nonpolar. And the last thing for today is just about solubility, which is how well something dissolves. So it's the amount of solute that can dissolve. But it depends on how much solvent you have, and it depends on the temperature and the pressure. So the first two words are relative to each other, and when I say relative, I just mean compared. So concentrated means that it has relatively more solute. There's not really a cutoff where it's like, okay, this is concentrated, this is dilute. But if you compare two things, you can say this is more dilute than this, or this is more concentrated than this. So you have to have two things that you're comparing for these two words. Relative has to do with the comparison. And if you're a visual person, this kind of helps. Dilute is where you have fewer particles in the amount of solution. So either you could just add fewer particles, or you could add more of the solvent to dilute it. If we're talking about absolute amounts that you can dissolve, the words are saturated and unsaturated. So unsaturated, it means that you don't quite have as much as you could possibly have. So if you want your tea to be sweet, you can add sugar up to a certain point, and then you just can't add any more sugar. Once you keep adding sugar, it'll just sink to the bottom of the tea. Once you've reached the point where you have the maximum, it's called saturated. And if you have less than that, we say it's unsaturated. And you can actually make a supersaturated solution. It's really difficult to do. You have to be careful with the temperature, and it's very unstable, which means it'll if you shake it, then it'll become a precipitate will form, basically. So you can have a supersaturated solution, but it's really uncommon. So let's look at this graph here. This is a graph you'll need to be able to recognize. Notice that temperature is on the x-axis, and the y-axis is the grams that you can dissolve into water. So each of these lines shows you how many grams you can dissolve into water at certain temperatures. And it's for lots of different chemicals, obviously. But the problem is it depends on how much water you have. If you have 1 drop of water versus a gallon of water, obviously you can dissolve a whole lot more into a gallon of water. So you have to set the amount of water constant, and that's why if you look at the y-axis, it's a whole long unit. It says solubility, but then it says grams of solute per 100 grams of water. So this graph only works if you have 100 grams of water. So if you find the first one, it says a solution has 132 grams of sodium nitrate in 100 grams of water at 75 degrees Celsius. So first you need to find the point where 75 degrees matches up with 132 grams. So find that with your pencil. And it should be right about here. Sodium nitrate is this line right here. So notice that at this point it's below the line, which means it is unsaturated. If it's below the line, it's unsaturated, on the line is saturated, and above the line is supersaturated. Let's try the next one. We have 95 grams at 50 degrees Celsius, so 50 degrees, followed up to 95, and then look at the KNO3 line, and notice that we're above the KNO3 line, which means it is a supersaturated solution. So again, under the line is unsaturated, on the line is saturated, above the line is supersaturated. And let's see, this one says that we have 90 degrees Celsius, and they want to know how many grams of KCl would dissolve. So if you go to 90 degrees, follow it up to the KCl line, and follow it over, it looks like it's just less than 55, maybe 54 grams can dissolve into 100 grams of water. So we're looking at how many grams can dissolve over here. Number 4 says that we have 200 grams of water. So this graph only works for 100 grams. We said that you can dissolve 54 grams into 100 grams of water. So if you double the water, you just double the amount that you can dissolve. So since number 3 was 54 grams, number 4 we doubled the water, so it becomes 108 grams. You just double the amount. And there's some practice with this graph on page 1 of your worksheet packet. So take a few minutes and go ahead and see if you can answer those questions on page 1.